quadratics, and we actually have already solved quadratics when we solved a function by factoring. So this is another technique that we can use to solve something that's a quadratic. And when we solve a quadratic, what we're doing is we're finding solutions to that function. And solutions are more appropriately referred to as roots or zeros, because when we plug those values back into the function, it causes the function to equal 0. But what we want to look at today here is what happens when we graph this function. So to start, we're going to start off by factoring it. And we have 1, 2, 3 terms in this one, which means that we need to split the middle on this one. So in order to split the middle, remember that the number in front of the x squared is a 1. So we're going to take 1 times 3, which is 3. And luckily, the only factors of 3 are 1 times 3. Will 1 and 3 ever combine to be 2? Tiffany?
You add the 1 to a -3.
1 minus 3. First. So again, we have factors that combine to be -2. So when we factor, we're going to rewrite this as x squared plus 1x minus 3x minus 3. And now we're going to factor by grouping. We have 4 terms. And when we look at our first group, our GCF in our first group is x. And when we factor that out, then we're left with x plus 1. We had 2 x's, we took 1 out. We have 1 left. We had 1 x, we took it completely out. Over here in our second group, we're going to factor out a -3 for our GCF. -3x divided by -3 is x. -3 divided by -3 is positive 1. So when we factor this, what we end up with is we have an x plus 1 in both groups. And then we also have an x minus 3 in both groups. Can you tell me the answer without doing the work? Matthew?
X plus 1 equals mutable. And x minus 3 plus 1.
If you can't do that, that's okay. Where it came from is we took x plus 1 and set it equal to 0. And then we subtracted 1 from both sides to get the x equals -1. We can take the x minus 3 and set it equal to 0, and we can add 3 to both sides, and we get x equals 3. I'm hoping that you're getting to a point where you don't have to necessarily show every little piece of work. Now, I like work, don't get me wrong, but I just don't think that you necessarily need to show every itty-bitty piece. But what we're going to do now is we're going to go to our calculators, and we're going to type this function in. So we're going to go on our normal screen. We're going to go to y equals, and we're going to type in x squared minus 2x minus 3 and let's look at the picture. There's our picture, which is roughly what we're going to have show up on our graph on our papers here in a minute. But let's find some values here. It says, using your graphing calculator, draw the graph of the function. Use the table in your calculator to plot as many key points as possible. So to get to the table, we're going to type in second and graph. And this gives us some values that we can possibly use. And right now, I'm just looking at are there any points on here that are going to fit on our graph? And it looks like negative 2, 5, negative 1, 0, 0, negative 3, and so on. So I'll write those down. Negative 2, 5, negative 1, 0, 0, negative 3, 1, negative 4, 2, negative 3, 3, 0, and 4, 5. And once we have them written down, we can graph those. Negative 2, 5. Negative 1, 0. 0, negative 3. 1, negative 4. 2, negative 3. 3, 0. And 4, 5. And here's a picture of a quadratic function. In fact, one of my better pictures of my quadratic functions. And as you finish up graphing here, start thinking about what's the connection between the graph of the function and its solutions. Remember, our solutions are x equals negative 1 and x equals 3. Do you see a connection, Jordan?
Yeah.
What is it?
They're
Just don't know how to say it? Really? The solutions are the roots. Need more information? Okay. They're both on the x-axis. The solutions are the x-intercepts. And I'm going to put there a comma because x-intercepts are sometimes called roots, which is why I said I needed more information. Again, what we found when we factored a moment ago is that negative 1 was a solution and positive 3 was a solution, and that's where Michaela came up with our x-intercepts. So that's what we're looking for when we solve these graphs, which is essentially what this says. The x locations on any function where the output, the y-coordinate, is equal to 0, not surprisingly, is known, not surprisingly, as the zeros of the function, the roots of the function, the x-intercepts of the function. Solutions are the x-intercepts, also known as roots and zeros. But as we switch over here to the next example, I'm going to pause the video for a moment. I want to talk to the Inspire graphing people for a minute. Typing in x squared plus 5x plus 3. We get our picture. Looks roughly like this. And we're going to have a little bit more of a sketch when we draw this over here on our graph. But look at what the first part says. It says, between which x values do the zeros of the function fall? Well, look at your calculator screen here. And what I see is that our graph falls between 0 and -1. And 1, 2, 3, 4, -4 and -5. You have to look at the picture on your graph to identify those two facts. Once again, between 0 and -1, between 1, 2, 3, 4, -4 and -5. So we can't tell specifically where this crosses. But we have an idea. And the thing is, because there's something that's in between, more than likely when we get to that next question, can we solve this function by factoring? I don't think so. We can't, because both of them are in between. It doesn't mean that we can't, but conceivably we can. So now, what it says is find the approximate values of the zeros, which remember are x-intercepts of the function, using your graphing calculator. Well, what I'm going to write down here are just a couple steps. So if you're not functional with your graphing calculator, this is for a TI-84, TI-84 plus, a TI-83. It's not for an Inspire. We're going to go second calc, which gets us up, I think, to the trace button. I'll have to look on my screen here in just a minute, and I might have that backwards. And then we're going to go to function number 2, which says 0 on it. So let me look here and make sure that I didn't go backwards on my value in my first statement, and I did. We're going to go to second calc, which is on the trace button. Inspire people, if you're good with the calculators, go to your menu, and I believe it's Analyze Graph, and it will also say 0. But I'm going to change this here. It's second trace. Sorry about that. Which gets us up to the calculate button. So I'll try one more time. So second trace, the second button gets us to the calculate button. And then we have a function called 0 right there. So we're going to use that. And what we're going to do is we're going to use our arrows here to scroll a little bit to the left of where our graph crosses the x-axis. My numbers at the bottom of the screen do not have to be your numbers at the bottom of the screen. In fact, I could scoot that down a little bit more. These numbers under left bound do not have to be the same as yours. Then press enter. Then I'm going to go to the right. So we're going to use the right arrow button. A little bit to the right. Again, our numbers at the bottom of the screen do not need to be the same. I'm going to press enter. Somewhere in between these two dotted lines, and some calculators show the dotted lines and some of them don't. Somewhere in between there is where our solution, our root, our x-intercept, our 0 of the function is going to be. It's going to be determined when we press enter. And what we ended up with is negative 0.697 is one of our zeros, which is really, let me say, negative 0.7. But we have two roots. I got the negative 0.697, bottom of the screen. But we really have two roots. So we need to find the other one. So we're going to go back to our calculator. And maybe we are. There we go. And I'm going to push second trace again. Second trace. number 2, the 0. I'm going to figure out our x-intercept farthest to the left. I'm going to arrow over. So somewhere around there. Again, your numbers at the bottom of the screen do not need to be the same as mine. Press enter. And then we're going to go a little bit to the right. Your numbers don't have to be the same as mine. But when we guess, there's going to be our other 0 of the function. So I'm going to write this down again. Our roots were negative 0.7 and negative 4.3. I neglected to graph that one, but you could go back at a later time and put that picture in. We at least have our screens to look at. So let's flip our papers over. Graphing a function to find its zeros, its roots, its x-intercept, its solution is helpful when quadratics, when factoring it is impossible. And that last problem that we just saw was one where we couldn't factor it at all. But let's look at this next picture here. And I'll try to graph it as well. We're going to go into our screen here. We're going to go to y equals, and we're going to type in 2x squared. Got to hit the x. 2x squared. Plus 3x. Minus 5. And we'll look at the picture. And I don't want to forget to graph again, so the next part that I'm going to do is I'm going to look at the table. So we're going to go to second and graph to get the table here. And there's a few points here, it looks like, that we can graph, like negative 3, 4, negative 3, 4, negative 2, negative 3, negative 1, negative 6, 1, 2, 3, 4, 5, 6, 0, negative 5, 1, 0, 2, 9. And I know it's not precise here. It's going to be a bit of a sketch, but we have a good picture on our screen, on our calculator, so that's nice. And the question is, based on the nature of this root, do you think that this function is factorable? In other words, can we identify any of the answers here on a graph? A root, an x-intercept, a solution, a 0? Well, my picture's ugly, but from the table I saw that value. One of our answers is going to be 1. The other root, and I'm going to check it on the screen because my picture's not that great, but if we go back to the picture on the screen, what I see is that we have another root between negative 2 and negative 3. But because we can identify 1, I think that we can factor it. So if we look at this one, again, it's going to be another split the middle. I did a little bit better in terms of spacing here on this one. We're going to take 2 times 5, and we get 10. The factors of 10 are 1 times 10 and 2 and 5. Will either one of those combine to be 3? Yes. Yes, they will. And in fact, if we do -2 and +3. So when we look at the factoring here, we've got 2x squared and we've got a -5. And then we can put -2x plus 5x back into your function. And we can factor by grouping. And in our grouping here, what we see is that the GCF of the first group is 2x. When we factor that out, we're going to be left with x minus 1. When we look at our second group, the GCF is going to be 5. And we're left with x minus 1. Which therefore means that we've got x minus 1. And then we have 2x plus 5. Singles. And what we want to know really is, well, what are our solutions to this problem? Well, we know one of them already. It's in blue over here. On our picture, it's x equals 1. But the 2x plus 5 is what we're going to have to use to help us finish here. And we can take 2x plus 5, and we can set it equal to 0. So we can subtract 5 from both sides to get 2x equals -5. Divide both sides by 2. And we end up with x equals -5/2. Well, just to check here, let's practice what we were just talking about a couple minutes ago, which is, what if we go to second and trace, which gets us to calculate, and number 2. And we go over here to the left. Again, your numbers don't have to be the same as mine. And then we go to the right. And your calculator may or may not show those lines. It's okay. But when we enter, we get -2.5, which is the same thing as -5/2. So let's try another one. Problem number 4. -3x squared minus 14x plus 5. We're going to type that in our calculator because we have to solve by graphing. We're going to go back to y equals -3x squared minus 14x plus 5. And let's look at the picture. And we're not going to see everything on the screen. Do we have, in general, an idea of what it's going to look like? Yes. Do we know the important information? Mostly, I'd say yes, because what does it say? It says solve by graphing. Solve by graphing means to find the x-intercepts. Can we find the x-intercepts on our graph with our picture? Yes. And what we see here is we've got 1, 2, 3, 4, -5 is one of our answers. And then our other answer is between 0 and 1. So, if we draw our picture, and again, there's not very many points on here that we can graph. We can graph this, which is -5, 0. And then if I look at my screen here, we can graph 0, 5. We don't have a lot to go on this one. 1, 2, 3, 4, 5. But what we do know is that when we go back and look at the picture, we want our picture on our paper to look something like this. So we want our other root roughly somewhere there. And there, it's a decent enough picture. It's a sketch, because we don't have very many points. It says, based on the nature of the roots, do we think that this quadratic is factorable? Well, once again, the answer is yes, because we have a -5 for a root. So we think it's factorable. And we actually haven't ever we haven't ever factored a problem where we have a negative in front of the x squared term. So what we need to do to factor this is we need to get that negative away from the 3x squared. So we're going to factor it out like it's a GCF. So we're going to take out a -1. And what that's going to do is it's going to change our 3x squared to positive. And it's going to change our 14x to positive. And it's going to change our 5 to negative. We have 3 terms here, and that means that we can split the middle. So we're going to take our 3 times our 5, which is 15. And the factors of 15 are 1 and 15 and 3 and 5. Well, either of those combine to be 14. Tiffany? 1 and 15. Which one's negative? Okay. So -1, positive 15. I'm going to ignore the -1 now. I don't need that to help factor. Put it in either way. I'm going to put -1x plus 15x. If you prefer the other way, put it the other way. It's not going to make any difference. And we're going to group. So in our first group, we have x. That's our GCF. And it's 3x minus 1. In our second group, the GCF is 5. And we're left with 3x minus 1. 15 divided by 5 is 3. 5 divided by 5 is 1. And what we see from our groups here is we've got the 3x minus 1 and the 3x minus 1 in both groups. And then we've got an x plus 5. And we already know that x equals -5. But what we don't know is we don't know what the other root is. We can take the 3x minus 1, set it equal to 0. So we can add 1 to both sides, and we get 3x equals 1. Divide those sides by 3. So we get x equals 1/3. Our other root is 1/3. You could check that by using your second trace button, second calculate button on your calculator, which is a nice feature to be able to use. As we finish here, the last problem, we're given a picture already. And it says, based on the nature of the roots, is this function factorable? What do you think? Because you can nod your head yes or no. What do you think? Is it factorable yes or is it factorable no? And at least the people who are nodding are right on the money here. Yes. And if we look really close here, what we see is that our graph crosses the x-axis here and here, where I just put those 2 orange dots. And in fact, we can identify those 2 orange dots as x equals -2 and x equals +4. what we want to do here in part B is it says create the equation that could represent the function. Well, we want to put it back into the format. We want to have something like y equals negative 3x squared minus 14x plus 5. So what we're going to do is we're going to add 2 to both sides, and we get x plus 2. With the 4, we're going to do the same kind of thing. We're going to subtract 4 from both sides. We get x minus 4. And then, to put it back into that format of ax squared plus bx plus c, we're going to multiply those two together. It's going to be y equals. We're going to multiply them together. And in order to multiply them together, that means 4. X squared, first terms, minus 4x, plus 2x, there's the inner terms, minus 8. Positive 2 times negative 4 is negative 8. When we combine our like terms, we get y equals x squared minus 2x minus 8. And if you type that function into your calculator, you should see the same picture on your paper as what you have on your calculator.